Right now, as you watch this, there is a city in motion. It doesn't appear on any map, it has no address, and no government officially recognizes it. But it exists, and it is larger than any metropolis you have ever visited. This city is called the Global Merchant Fleet, and it lives on the ocean. More than 50,000 commercial vessels are sailing simultaneously across the world's seas at any hour of the day or night, carrying everything you use, wear, eat, and depend on economically. The phone in your hand right now, the shirt on your back, the components that make your car run. All of it crossed the ocean inside a steel box, aboard a ship that very few people have ever seen up close. What makes this world even more unsettling is this. Most people have never stopped to think that it exists. We live in a global consumption system where any product arrives at our door with just a few clicks. But what lies behind that magic is an oceanic machine of incomprehensible scale, running 24 hours a day, 7 days a week, 365 days a year, with a surgical precision that would put any industrial process on land to shame. And it all begins in a place most people will never visit, the open sea. Before we continue, don't forget to subscribe to the channel, like the video, and hit the bell so you don't miss the next adventures through this world that seems unknown to so many. To understand the scale of what we're talking about, forget for a moment the numbers you already know. Think of it this way. Approximately 90% of everything traded between countries arrives by sea. Not half, not most of it, 90%. That means if ships stopped today, supermarket shelves would be empty in less than a week. Pharmacies would collapse within days. Factories would shut down for lack of components within hours. The system that sustains modern civilization is not in data servers, not in airplanes, not in satellites. It is floating silently in the middle of the Atlantic, the Pacific, and the Indian Ocean, guided by a crew that sometimes has fewer than 25 people to control a structure the size of 4 football fields. The question nobody asks is, how is this even possible? How can a machine this enormous be operated by so few people, survive oceanic storms, avoid other ships, navigate the narrowest canals, and still deliver every single box to the right place, undamaged, almost always on time? The answer to that question will completely change the way you see the world around you. And it starts with the most astonishing structure ever built by human hands. But building this giant was not the greatest challenge. The real problem was figuring out how to keep it upright. Because the physics of a ship this size defy everything human intuition can calculate. The world's largest container ship in operation is nearly 400 meters long. Stand it upright, and it would be taller than any skyscraper in Europe. But the number that really keeps engineers up at night is not the size, it's the weight. When fully loaded, this vessel moves more than 250,000 tons. For comparison, the Eiffel Tower weighs approximately 7,300 tons. In other words, we're talking about the equivalent of more than 34 Eiffel Towers floating simultaneously on the water. And not just floating, moving at 21 knots, nearly 40 kilometers per hour, cutting through waves that could sink a mid-sized warship. The engine that drives this structure stands as tall as a 4-story building, weighs more than 2,000 tons on its own, and produces up to 88,000 horsepower, the equivalent of running hundreds of high-performance sports cars all at once. This engine burns between 250 and 300 tons of fuel per day, which sounds absurd, until you discover that per ton of cargo transported, a ship consumes 10 times less fuel than a truck. It is the most energy-efficient form of transportation ever created by humanity, and almost nobody knows this. But the true genius is not in the engine. It lies in what no one can see, the balance system. A ship of this size carries containers stacked in towers the equivalent of 22-story buildings. The center of gravity of this structure is dangerously high. If nothing were done, any strong crosswind or sharp turn could trigger what engineers call a healing moment, and the ship would simply capsize in the middle of the ocean. To prevent this, every modern vessel relies on a sophisticated system of ballast tanks spread across the bottom and sides of the hull. These tanks are enormous reservoirs that can be filled or emptied with seawater within minutes, redistributing the vessel's weight in real time. Computers monitor the ship's tilt second by second. If sensors detect any deviation from the ideal position, pumps are automatically activated and tons of water shift from one tank to another to correct the balance, all while the ship is in full motion, in the middle of a storm, with 6-meter waves crashing against the sides. And there is yet another secret hidden inside the hull. It is divided into watertight compartments separated by welded steel walls. Even if the hull is punctured, only one compartment floods, and the ship keeps floating. Modern naval engineering has built a structure that is at once the largest and one of the safest ever placed on the ocean. This extraordinary engineering solves the balance problem. But there is another challenge that no computer can solve on its own: what is inside those containers, and the silent danger that grows as the ship sails on. Aboard this ship that moves the world, between 20 and 30 people live. Just that. To operate a structure worth hundreds of millions of dollars, carrying cargo valued at over $1 billion, crossing oceans for 40 days straight, the entire crew would fit comfortably on a school bus. These men and women, because yes, there are women in the merchant navy, though still in small numbers, work in shifts of 4 to 6 hours, sleep in individual cabins with showers, air conditioning, and satellite internet. They wake up at 7 in the morning in the middle of the Indian Ocean, have breakfast in the mess hall as the sun rises over a horizon that is nothing but water in every direction, and spend their days managing one of the most complex systems ever created. The captain of this vessel is responsible for a cargo equivalent to the annual budget of a mid-sized country. Every decision he makes, rerouting due to a storm, slowing down to save fuel, negotiating entry into an overcrowded port, carries financial consequences worth millions of dollars. And he makes those decisions alone, at 3 in the morning, 2,000 kilometers from the nearest coastline, with the wind howling and waves hammering the hull like giant sledgehammers. It is not a job for everyone, and the salary reflects that. Chief engineers and captains earn between $8,000 and $15,000 a month, but spend months away from home, away from family, away from solid ground. But the ship's crew is only a fraction of the parallel civilization that surrounds maritime transport. In the ports, the story is completely different. The world's largest port terminals, Shanghai, Singapore, Rotterdam, Los Angeles, are cities within cities that never stop. In Shanghai, the port handles more than 47 million containers per year. That means every single second of the day, somewhere in that terminal, a crane is lifting a 50-ton load. The cranes operating in these ports are monumental mechanical creatures. Each one stands as tall as a 20-story building and can lift a full container in seconds with centimeter-level precision, guided by operators in air-conditioned cabins, working with joysticks and high-resolution monitors. In the most modern terminals, some of these operations are already carried out by fully autonomous cranes, guided by GPS and artificial intelligence, with no human operator at all. The time a giant ship spends in port is surprisingly short, between 12 and 24 hours. During that window, dozens of cranes work simultaneously, removing and inserting hundreds of containers, while a central computer system tracks the exact position of each of the 24,000 steel boxes and recalculates the loading plan in real time to ensure the ship's balance is perfect before it sets sail. It is a choreography of iron, data, and precision, and it happens while you sleep. All this operational perfection, however, depends on something no technology can fully control: the routes. And some of these routes hide bottlenecks so critical that a single grounded ship was able to cost billions of dollars to global trade in a matter of days. There is a set of maritime routes that, if they disappeared tomorrow, the world as we know it would simply collapse. The most critical one passes through a canal less than 200 meters wide at its narrowest point, the Suez Canal in Egypt. Through this crack in the desert, more than 19,000 ships pass annually, the equivalent of one ship every 28 minutes, 24 hours a day. They carry approximately 12% of all global maritime trade: oil, electronics, food, automobiles, pharmaceuticals. In March 2021, the world discovered what happens when that flow is interrupted. A single 400-meter container ship ran aground in a bend of the canal and completely blocked traffic for 6 days. Within 24 hours, more than 400 ships were stopped and waiting. Estimated losses reached $9.6 billion per day. Factories in Europe shut down for lack of parts. Supermarkets began calculating how long before their shelves ran out. Oil prices rose across the entire planet, all because one ship, a single ship, got stuck sideways in a canal for 6 days. The Panama Canal, on the other side of the world, faces similar pressure. The Strait of Malacca, between Malaysia and Indonesia, is a passage through which more than 80,000 ships travel per year, one of the busiest and at the same time most dangerous routes on the planet, historically associated with piracy and geopolitical instability. What few people realize is that maritime routes are not created by chance. They follow a logic of winds, ocean currents, seafloor depth, and distance between ports that took centuries to map and refine. The typical route from Shanghai to Rotterdam, for example, covers more than 20,000 kilometers, crosses 3 oceans, 2 seas, and 2 artificial canals, and takes between 30 and 40 days. Along each stretch of that journey, the ship faces completely different conditions. The Indian Ocean can have absolute calms that increase fuel consumption. The Red Sea can bring violent headwinds. The Mediterranean can have extremely heavy traffic with near-zero visibility due to fog. To navigate each of those stretches safely, modern ships are equipped with an automatic identification system, the AIS, which continuously transmits the vessel's position, speed, and heading to all other ships and Coast Guard services within range. It is the maritime equivalent of an air traffic control system, but for the entire ocean. And even with all that technology, local pilots, specialists who know every bend, every current, and every meter of the seabed in canals like Suez and Panama, board the ship to personally guide it through the most critical stretches. Because when a mistake means blocking 12% of world trade, there is no such thing as too much caution. But the routes are only the path. What truly determines whether this system survives into the future is something happening right now, silently, in the shipyards of South Korea, China, and Europe. A technological revolution that will change the ocean forever. The maritime industry is in the middle of the greatest transformation in its history, and it is happening underwater, far from the eyes of the world. The first major axis of this revolution is fuel. Ships powered by heavy fuel oil, the dirtiest type of petroleum derivative in existence, are responsible for approximately 2.5% of all global CO2 emissions. That may sound small, but it is equivalent to the emissions of all of Germany in a single year. Pressured by increasingly strict international regulations, shipping companies are betting on alternative fuels. Liquefied natural gas is already a reality on dozens of modern ships and reduces sulfur emissions by nearly 100%. Green hydrogen and ammonia are in advanced testing phases and promise to bring carbon emissions down to zero entirely. At the same time, engineers are reviving an idea centuries old with 21st century technology: sails. Not the cloth sails of historical galleons, but rigid structures of metal and carbon fiber, known as Flettner rotors or suction sails, that capture wind energy and can reduce fuel consumption by up to 30% on favorable routes. Some ships are already sailing with these structures installed, and the results are surprising even the most skeptical engineers. The ocean, which for centuries was ruled by the wind, may be on the verge of being moved by it again, but in a way no sailor from the past could ever have imagined. The second revolution is even more radical: autonomy. The first fully autonomous ships have already completed real crossings with no human beings on board. The Yara Birkeland, a Norwegian electric and autonomous vessel, began commercial operations on a coastal route in 2022, with no captain, no crew, guided only by cameras, sensors, artificial intelligence, and remote control systems operated from land. The technology that makes this possible is the same that powers self-driving cars, but adapted for a far more challenging environment: the open ocean, where there are no painted lane markings on the road, where visibility can drop to zero in seconds, and where a single mistake can mean losing a billion-dollar cargo to the bottom of the sea. But perhaps the most telling data point about the future of maritime transport is this: even in the face of wars, pandemics, and global economic crises, the volume of cargo transported by ocean keeps growing. The largest companies in the sector, MSC, Maersk, CMA CGM, expand their fleets every year. A single container ship replaces the work of 3,000 trucks in a single voyage. It is low-cost maritime logistics that makes it possible to manufacture a cell phone in Asia, a piece of clothing in Bangladesh, and a car in Germany, and sell all of it at prices that fit in your pocket. The invisible city in the middle of the ocean is not a curiosity. It is the silent foundation upon which all of modern civilization was built, and it will keep sailing, whether you know it exists or not. If you made it this far, thank you for coming along on this adventure. Subscribe to the channel, leave a like, and hit the bell. because there's still a lot of unknown world left to explore together.